So that in all those lessons it was sine and cosine, not the other four trig functions. So today you're doing all the other four trig functions and powers thereof all in one lesson. So I hope you're on your game. Are you ready?
Oh yeah.
Okay, here we go. You might have memorized that the antiderivative of tangent is the log of secant. But can you tell me why that is?
Because it's upside down.
Okay? What? What do you mean it's upside down?
It's the up and down, and then it goes to
The up and the down? Can you be more specific?
the
Or be
numerator and
coherent?
the denominator.
I still don't follow you.
You know what? I follow me, and
That's all that matters.
self-worth comes from inside home.
Let's go here. Do you agree that tangent is sine over cosine?
Yes. That's
Okay.
what I just said.
No, no. Okay. And by u sub, u is cosine, and therefore du is negative sine. Now that negative is a problem. If we move that negative over to isolate what we actually have for the u sub, then our antiderivative or integral becomes negative 1 over u du. Because of the cosine having a negative derivative, we pick up a negative. The antiderivative is negative natural log of the absolute value of u, which is negative natural log of the absolute value of cosine. And there's nothing wrong with that, really, but it's most often cleaned up a little after that. How does that negative and cosine combine to be a secant? Think of log rules. That's a negative 1 out front. So if that's a negative 1 out front, then it can be moved to the exponent. So this is log of cosine to the negative first. Now that's not inverse cosine, by the way. Those notations are a little bit confusing, but that's, man, I should just take these out. That's 1 over cosine, so natural log of secant. With me? Okay. Would you do the other one, please? Which is actually the easier of the two.
Am I wrong? No.
Your question is to show why it is, not that it is. You're telling me that it is. You're showing why it is.
You should probably learn something.
Are we ready?
Oh, man.
Did that go okay? I just ignored your note.
I know.
No, I wrote.
Oh, this is not the
Okay. All right, moving on to more challenging prospects. Okay, so tangent squared, cotangent cubed, tangent to the fourth, basically powers of tangent and cotangent. I have a couple notes that you'll need, but I want to add a few more. First of all, you need to know your identities. The tangent squared plus 1 is secant squared. Do you remember that one back from trig?
Yes.
Okay? And 1 plus cotangent squared of the cosecant squared. You need to have those memorized. As much as I'm not big on memorization, it's necessary. Okay, you'll also need to recall some known derivatives. Wouldn't you agree that if you could get to secant squared as an integral, then you'd be home free because the antiderivative of secant squared is tangent. And likewise, if you could somehow manipulate to get to secant tangent, you would be home free because the antiderivative of secant tangent is secant. Likewise, the negative versions, if you could get to cosecant squared, the antiderivative of that is negative cotangent. And if you could get to cosecant cotangent, the antiderivative of that is negative cosecant. All right, so those are all based on known derivatives switched out in the opposite direction. You with me? Now keep those in mind then as you go here. These are not all, each one's a little different. They require a little bit of thinking, and let me make very clear to you, there will be some trial and error involved. Don't think that because you tried something that didn't work, you say, oh, I quit. That one thing I tried didn't work. Let's give it up. You try something else. You go at it a little different angle. It's kind of like identities and trig. You tried this one, it didn't quite work out, so you back up and try something again. That's part of the process. The more you do, the better you'll get. So let's look at that first one. Say you had to integrate tangent squared. You could do a lot of different things. You might say sine squared of cosine squared. Now that wouldn't actually go anywhere because the u sub wouldn't work there. You have another identity, or oh darn it, I just told you. Do you have another idea?
Identity.
Good job. So the tangent squared can be substituted in for with secant squared minus 1. Now that's wonderful because, first of all, our good integral basics tell us that yes, it is okay to separate an integral of a difference into two separate integrals. Is that the case in every math operation that you can separate the integrals? Or just addition, subtraction?
No.
Yeah, just addition, subtraction, and we know we cannot separate multiplication, division, right? Okay, so what is the antiderivative of secant squared? Tangent. And the antiderivative of what? X. Throw on a c, you don't need two c's, although there are two integrals, we just use one general c. And we're done. Is that cool? Pretty easy. Try thinking through cotangent cubed. I want you to have a minute or two to give this a go. It's totally different, obviously. But think it through, and we'll go over it in a minute. We'll go over it in a minute. Well, of course it's possible. It's right there at your fingertips. What do you got? What do you think I could do? Give me something. An identity, yes. Cotangent squared is cosecant squared minus 1. Right? Now, anticipating ahead a little bit, that doesn't feel quite like u sub because the derivative of cosecant squared would definitely not be cotangent, right? However, the derivative of cotangent is cosecant squared, then the 1 is kind of in the way. So, what should I do? Separate them into cosecant squared cotangent minus cotangent. Now, anytime you're going to u sub, you should always split it. You can't, it's bad math to u sub saying, I'm only going to u sub this, but not this if it's all one integral. If you're going to u sub part of it, it needs to be split. So, in this case, u would become cotangent. Pretty weird that the lesser powered term is my u. Usually it's the opposite. The greater powered term is my u, and the lesser is du. But it is what it is, I'm sure. Wouldn't you agree that you do pick up a negative there? So upon substitution, this is really more like negative u du. You agree? Okay. The antiderivative of which is negative 1/2 u squared, which in the interest of time I'm going to integrate and sub back. Negative 1/2 of cotangent squared. Now we get on the first part. Second one's easy because you already did it. It's right at the top of your paper. The antiderivative of cotangent is natural log of sine. Say you were doing a multiple choice test, and that second term there wasn't there. What could it also be? You could maybe see how it could also be possibly positive log of cosine. See what I'm saying? You do that stuff. Okay, are we cool? Assuming you're silenced, you're great. Tangent. Did I make an error here? You're really quiet. Are we good? Okay, it's really okay. So Rachel's close to sleeping. That's cool. You're tired? Maybe we should all stand up and do a little.
Go outside.
Yeah,
Go outside.
I was thinking more like moving around for 1 second and then getting back to work. I think you might
On
throw
the
up.
sidewalk with chalk.
Sidewalk chalk? What, are we in preschool here? Sidewalk chalk napping? What the heck? You're learning calculus. All right.
I woke up at 4 trying to dream that there was a bug on my hand, and like it was
Just
traumatic.
a little. Okay. Good. I'm sorry. All right. Tangent to the fourth. Working our way up to more complex. What do you think we could do?
Split that, baby.
Split that baby into tangent squared. Well said. Tangent squared, tangent squared. Okay? Then give me something we could do. Identity, yeah. Goes secant squared of 3x minus 1. Then the question is, shall I do that to both or just one? Well, if I do it to both, I'm going to start to get secant to the fourth, and that seems like making it worse, not better. So I'm going to just do the first one only. Okay? Now you might, depending on your skills as a mathematician, you might see it all from here. It's pretty close. What could you do?
Split that, baby.
Split that baby, yes. Tangent squared 3x secant squared 3x. It's one integral minus tangent squared 3x there. Now, what about that first? Be careful here. That 3x is now going to cause you to have
Why is secant cubed?
Okay, so what?
Why is secant cubed?
It's not. It's. Sorry, my bad. Secant squared. All right, so let's talk u sub on that first one. What shall we make u? Too much. Too much. Or too much. Tangent. Tangent squared or just tangent? Just tangent. Now be careful here. Du is actually 3 secant squared 3x dx. So when I go to substitute, I'm actually going to have a 1/3 moving over, right? So with u substitution, this becomes 1/3 u squared du. Stop me if you disagree. The antiderivative of that then is 1/9 u cubed, and u the whole time was tangent. So our first part is 1/9 tangent cubed of 3x. Are we good? Okay, let's go back to the tangent then. How do we approach tangent squared? That should look familiar. Identity, yes. This then is secant squared of 3x minus 1 dx. Maybe we could u sub that. We could maybe mentally do this. Do you agree that if we u sub that, u would be 3x, du would be 3 dx? So we need to have a 1/3 of what? Tangent of 3x, is it minus x or plus x? plus x. Make sure you distribute that negative. See that negative and a negative? Plus x, right? Plus c. Is that clear? Okay. Okay. Time for a. Did you say that's a lot of work? That's really not.
That was kind of.
All right. No. Okay.
Do you see the boxes we have? Those are huge.
Can I make a suggestion? Yeah, like on
You'll be-
a small portion bigger.
Okay. This is what I think of as a deserted island problem. Could you, if you were on a deserted island and had all the time in the world to think through this, could you tell me what the antiderivative of secant is? Now the reason is, it actually takes a little bit of creativity. At the highest levels of math, it's really a very creative endeavor. Those are some of the most creative people in the world. They think in a just totally different way. This is one of those problems. You really have to approach this in a different way. And in the interest of time, I'm going to start to just kind of guide you there because I usually let you flail around and see what fails.
Root 10 squared plus 1.
Um,
Tell me yes or no right
So here's a candidate. One person might say, what if you just go this? And of course that goes nowhere.
now.
Is
Not
that-
what I said at all.
That's not. Another candidate, maybe what you said is to say, hey, can I square root and square secant squared? Now that
That's not what I said.
makes, okay, well, these are from past experience, things that people
That's also
try,
not what I said.
and also it doesn't get there. Now, Rachel, what did you try?
I said root over the tan squared u plus 1. How do you do it?
Root, say what?
What did you
Root
do
of
the root?
tangent?
No!
What are you talking about?
Do a square
that
root
big.
sign.
What?
Do a square root sign.
Square root sign.
And then inside is tan squared u plus 1.
Tangent, oh, I see. Tangent squared
Since you don't recognize it.
x plus 1. Is that what you're saying?
Yeah,
Okay, super. Then what?
that's not my problem.
Oh, yeah. So that goes nowhere. I can assure you that's definitely not it. Good try, though. So this is where it starts to get a little, like I said, creative. So these are don't work. Boom. Okay? Instead, so think of bringing in something. That's the creative piece. It seems like a step back, but you're going to multiply in by something that helps you. Now, if you're going to multiply, you have to balance it. Mathematically, you balance one of two ways. If you have an equation, you can multiply both sides of the equation by that thing. But if you have an expression, which is what you have, then you have to multiply it by the thing over itself, or a factor of 1. So now, think of what you might multiply by so that you might get something that's a nice derivative. Tangent makes a lot of sense, and that's absolutely what I tried, because that gives you secant tangent, and that's a good idea. Unfortunately, that's not the right du for that u. So good idea, but not quite. Give me another thought. Secant would make sense. I don't know if somebody said secant, but secant would make sense because secant squared is good. But again, it's a mismatch. So then some genius said, I know what I'm going to do. It seems like secant is closed, tangent is closed. I'm going to multiply by secant and tangent.
What? See,
Now.
I look at this most days. Look how ugly that is.
Could you get that? But it's not going to be ugly for very long. Okay? Could you have got this on your own in a deserted island? Because you have nothing else to do. You want to occupy your mind.
When you're gathering coconuts, your mind
This is what you're thinking about while you're gathering the coconut.
What are you going to write on?
Okay?
coconuts.
It's all in the same way. You made papyrus.
What type of island did you go
Okay. The first I would make papyrus so I could do math, and then I do math. Yeah, it's like ancient paper.
Where's
Okay.
your food? Tell me that. You
Food,
eat
math
today.
first, then food. So what's you?
You won't be doing much math.
What's you?
Secant x.
You, join us in the back. You three. No? Did you give me no? I didn't know you could actually say that. No, I'm kidding. What's you, Mitch? Yeah, there you go. U is secant plus tangent. Now that's actually great because du then is there. It's secant of x, tangent of x, plus secant squared, all dx. And so it becomes a nice clean 1 over u du, which is natural log of u. And therefore, the antiderivative, which you will probably want to commit to memory, so you don't have to show all this process, is the natural log of secant plus tangent. The absolute value of that plus c. Okay?
See, and if you run a deserted island, you wouldn't be able to share that. Yeah, now you're
Yeah.
Have an incentive to
self-satisfied
escape.
and dead.
That's right. You would then you would really be you'd have a motive to escape so you could share it with the world.
Your notes.
Try the next one, please, on your own.
If your mom
You might consider it negative.
and your first thought is
Yeah,
like,
please derivatives here involve a negative.
I have a feeling you don't want to go back to
Think a negative in there. You might need a negative because these derivatives involve negatives. This is 14. Yeah, we had 4 periods already, and we're only in 3rd period.
Yeah. Hey, guess what? We had 3 periods in the first period. So I only,
2 periods?
no, a free period, then the study time, and then the class. Yeah, I really could have, okay? I really
So that's what your point is. You put it here.
I'll come 2 hours late.
Yeah.
No, we're doing so.
I did like,
That's why they didn't start the very good.
yeah, it's the only time. I told I was like complaining to my mom, she's like, no, yeah, and it's really.
How are you? Just ready to see you. Are you actually? You're not even ready to Okay. All right. It seems like you're just waiting for me to put it up there for you and be accepted. You're still waiting cotangent minus cosecant? Or is it cosecant minus cotangent? I don't know.
There you go.
Cosecant minus cotangent over itself?
Up and then you do it down.
Let's see if that goes anywhere. So I get cosecant squared minus cosecant cotangent over cosecant minus cotangent.
Yeah.
Okay, so what's your u? Cosecant minus cotangent. Let's see if we need to do some sign manipulating. Derivative of cosecant is negative cosecant cotangent. Hey, look at that. It's already negative. That's perfect. Plus cosecant squared. Also already positive. So you didn't actually even need a negative in there. The sign worked out. It's just 1 over u, right? So the natural log of what? Cosecant x minus cotangent of x. Let's see.
Wait, so will the U always be what you plug in?
The u will always be the denominator. For these is the denominator. Okay? All right. So, as much as you can by memory, the antiderivative of cosecant is? It's like cosine over sine, natural log of sine.
Oh, shoot.
Oh, wait, I'm already, sorry, I was thinking cotangent, I'm sorry.
Wow.
So, cosecant is natural log of? The one you just did,
Yeah.
30 seconds ago.
Yep.
Cosecant minus cotangent. It's got a negative in it. The antiderivative of secant is natural log of secant plus tangent. Tangent comes from sine over cosine, but you pick up a negative, so it's natural log of secant plus c It's really negative log of cosine, but that's usually cleaned up. And cotangent is cosine over sine. It does not involve a negative, so it's just log of sine. Okay, you eventually want to get those into your grade.
That's more clear than the other one.
See, why not just leave it as this? That's the other form. Why can't you leave it as an integral?
This looks so much better that way.
So that's like a fourth grader saying, why can't I just leave it like that? Well, why do I really need to know what fourth grader is?
Well,
Just leave it like that. That's the question. You want the answer to the question. Right. Whoa! I have no idea why this slide is even there. What is this quote? No, I have no idea where this is coming from.
And now is that we skip number 4 of our question.
It's documented. I have no idea where that came from. Okay.
I'm gonna ask last one in class, because they got to skip number
Homework. I think that last year I did this the day before spring break, and so last year they had homework over spring break. You didn't have homework over spring break.
I already did the first course, how about we skip 4 questions?
All right.
Is that all right?
I'll suffer too.
What time do we get out of here? It must be 12:15. Okay. All right. So
Took me a while, just like staring at it.
answers to these real fast. We don't usually. Our book doesn't usually do just expressions for differentials, but it's really just the idea of if you want dy, then it is f prime of x dx, and you're not actually doing a numerical value. So in these cases, you should just be taking the derivative and times the differential of the independent variable. So in this case, it's the derivative times dt. The second, you had to use the product rule carefully, and the chain rule, but it's then times dx. And the last one, you had to use the chain rule and dz. Okay, are those cool? This one, when I did my key, I didn't see that minus x off to the side, so all my answers are wrong. Is this just on the quick trying to, did you get something like 0.0835 there?
0.0885.
85?
0.085.
That's delta y, the true change is if you actually put in 2.03, actually put in 2 and subtract. That's the true change.
We have to find that delta y?
I got your answer. I did that.
Because you got 0.884.
I rounded to 24.
Okay, so we must have.
0.084.
Okay. All right. So when they ask for a true delta y, the true change, you're actually calculating the true values and seeing the difference between the two. True. dy, the differential case, is where you use the derivative to approximate. It's the derivative times the differential. This was 0.085. They are fairly close, as should be the case as long as your delta x is small. Okay. The second one was a business calculus from a business calculus textbook. This is called marginal. When you talk about the cost of one more, that's marginal profit or marginal cost. The true change in cost, the true cost of the 301st, you first have to know what the heck C does. C gives you the total cost of this many things, widgets. So really the only way to get that 301st widget is to say what's the cost of 301 and subtract away the cost of the first 300. That therefore is the 301st. The difference must be how much that 301st cost was $295.91. If you use it in a differential form, based on the rate of change at that first instant, it would be about $296 for one more. So you can see the point of this is comparing the true change to how our estimate would come out, and our estimates are pretty good. You with me? All right.
Yeah.
Okay. Estimating the new value, and we've done that quite a bit, so hopefully that went well. 3 and 1/6. The next one was a little wacky. You first never do calculus in degrees, so you needed to first convert 31 degrees to radians. 31 degrees is 31 pi over 180 radians. Okay? After that, I said sine of 31 pi over 180 would be like sine of 30 pi over 180, which is like sine of pi over 6, plus some change. Okay? I started as a good point close to 31 pi over 180 is 30 pi over 180. 30 pi over 180 sine of pi over 6 is 1/2, plus the derivative idea. This needs to be basically in every problem. That is the basic concept that needs to be shown. With that then, and the derivative, this is where the answer came from. 1/2 plus root 3 over 2. That dx is 1 pi over 180 away. Is that clear? Ish? Is that the end of this? Yes. For number 4, the gray problem. The estimate, I actually read this, what is the maximum error? I wasn't sure if they were getting at, do they want me to actually find the true delta V, or do they want me to estimate and use differentials? Really, in a good problem, they should be saying use differentials to estimate the true. I read it that way, so I'm using dV, differentials as an estimate. So my dV is 16 pi. The relative error, which is dV over V, is 0.0015, and then making that a percent error, that's 0.15%. For the radius, that actually seems hard, but that's easier because they give you everything you need. The relative error for the radius is 0.01 compared to 20, and so that's 0.0005 as a percent. Move the decimal twice, that's 0.05% error. It's pretty common, in fact, almost always the case that as you go up in dimensions, you get more error. So if you talk the linear measure of the radius, and as you go to the surface area and the volume, that error will grow. Okay? The edge of the cube kind of problem. You want to talk volume and surface area. The volume could be off by as much as an estimate of 270 cubic centimeters. The relative error in the volume then, dV to V, is 100th, and that as a percent is 1% relative, or percent error in volume. Okay, for the surface area, the error could be as much as 36 square centimeters. Relatively speaking then, ds2s is 0.006 repeating, and as a percent, that's 0.6%. Yes? Sure. Yes? This is the volume part, this is the radius part. Pretty cool? Sure. Okay. These are probably pretty okay. The second part of the fundamental theorem, tangent. When the limit, the x is in the lower limit, you have a negative then, negative natural log minus root x. And then the last one involved the chain rule. Make sure you use the chain rule. E to the 6 root x times the derivative of 3 root x, which is 3 over 2 root. Just make sure you use the chain rule. Cool? Okay. Number 7. When you estimate the natural log of 7, it's the area under the 1 over x curve from 1 to 7. That then would take 9 trapezoids. Sorry, I thought I was making this so it required 4, but I screwed up. So required 9 trapezoids. If you look at the region from 1 to 7, and you break it into 9 trapezoids, that's a total region of 6 divided into 9 trapezoids. each change is 2/3 wide. So the first one would be something like 3/3, then 5/3, 7/3, 9/3, 11/3, and you continue on until you get to 21/3. You may use a calculator. You got a common denominator between 9 different.
No, I just left
did
it
that,
like
but I got
this.
it.
Yeah, I just kind of.
Hey, 1.9808 is the decimal form. I also have the fraction form if you're interested. That was the idea though. Okay? For the next one, if you're talking the natural log of 13, that's the area under the 1 over x curve from 1 to 13. That then would mean from 1 to 13 is a total region of 12. You're dividing that among 5 trapezoids. When you did the air bound, you saw that it required 5 trapezoids. So you should be working with something like 17 fifths and 22 fifths, or 17 fifths, 29 fifths, 41 fifths, 53 fifths, and then 13. Your estimate was 2.93108. And that's good. Okay, and then last but not least, for the volume / area problems, A was, correct me if I'm wrong here, I might have errors, 0.0647. The area of S is 0.4103. We don't agree with this?
No, I agree with those.
Oh, okay.
Please don't change.
C, 4.5587. D, 4.068.
Yeah, I disagree.
Disagree with this one?
No,
I'm good with that.
I disagree.
C and D.
It's even.
Sorry, E at 0.1611 and E at 0.0138. No, we have some question about this.
Are we turning this?
Do turn them in. We'll go over questions tomorrow. I just want to check that you did them. If you have an error here, there, that's okay. We didn't have to post. They are good today. Have a great day. That was the bell.